Thank you, Victoria. I'm reminded by her remarks that large-scale computation of complex systems may actually be possible in the very near future because quantum computing is leaping ahead at a surprising rate. And it wouldn't be surprising to see it next 10 years, 15 years, that this kind of large-scale computation of large-scale systems may indeed be possible. Those are prescient remarks. I would like to introduce Kay Dickersin, our next speaker.
Thank you all very much, and Victoria, thank you especially because you got me thinking about what I want to say, and I'm sure I'll forget half of the connections, but maybe the audience can remember them. All right, so I just have to see how to move forward here. Okay, let's move forward. Let's try this now. Okay, so in public health and medicine, we have a declaration of interest, and I'll just tell you, I don't really have any financial conflicts of interest other than funding to study some of this stuff. So this is sort of a quick addition this morning, but I thought this is the statue outside the front here on Constitution Avenue of Albert Einstein, and this isn't actually what the quote looks like, but because of shadows in the morning, I couldn't get a good picture of the quote, but I found this on the web. The right to search for truth also implies a duty. One must not conceal any part of what has recognized to be true. And I think that to some extent, this has to do with what we're saying. It's not just concealing, but it's also we have a duty to tell everything so that it can be understood and transmitted to others. So I'm going to talk somewhat about publication because that's really how all of us scientists communicate our findings from our research is publications. And yes, we do it at meetings like this, but also we really rely on those publications, the methods sections, et cetera, to tell us what happened during the experiment or during the study. And for the most part, we're reliant on public sources, that is, journal abstracts. And most people, I think, don't rely on them, but we do to some extent, and it is how some information is transmitted. So I'm going to leave that there. But journal articles are the main way that information is transmitted. We also have in clinical trials and observational studies, so in the clinical sciences, study registration, and Roberta Scherer is going to talk tomorrow about that some more. And then as clinical scientists, we can get information from regulators such as the FDA about the information they receive. But there's also a lot that we don't see, and that's somewhat what I'm going to talk about. We have unpublished manuscripts, and Victoria mentioned the file drawer problem, in that a very human nature thing is to keep within ourselves maybe manuscripts that are less compelling to get out there because we never have enough time. And it may be those are the ones with the negative results, whatever those are. We also, although this is changing, have data sets that we may be keeping ourselves, especially of older studies, while now I think we're more geared towards making those data sets available. And then it's not good enough just to get the data set. You also need to get the metadata, the information that helps you discern what's in the data set. So Victoria mentioned the reporting standards that we have, and this really, in the clinical sciences, and I'm in public health, even though I used to be in cell biology, so I'll try to make that connection when I can. But in the clinical sciences, we started talking about how information is reported, as far as I know, back in the 80s, before that for sure, but in a formal way. And there were articles about how to read and how to write, user's guide, how to make abstracts more informative, and now we use a structured abstract a lot, which is, I love, it's absolutely helpful. We had, starting in 1989, a peer review Congress, and that's held every 4 years. It'll be this coming year in Chicago in September. And a lot of people talk about the problems of publishing and the issues, and we have journal editors and others here who can help us with that conversation. And then traditional reporting standards that came out starting in the 90s for clinical trials first, and now we have the Equator Network, which has all kinds of reporting standards. This doesn't mean that the journals have applied the standards, and now we'll have to also talk about some of the computational standards that need to be there. I agree completely. But at least people have developed these standards. They aren't necessarily applied. The Institute of Medicine has also been involved for many years in various aspects, and I'm only recording here the recent and 35 years before reports on data sharing. And so as long as I've been in the field of clinical trials, which are clinical experiments, we've been talking about sharing the data from clinical trials. And it goes on, and I think we're getting closer, so that's really great. So the IOM report, Institute of Medicine, as it was then called, now National Academy of Medicine, made some of the same recommendations, but we really have made progress, so I'm not going to go over the things that have already been accomplished. And one of the advantages that we were talking about last night of recommendations made in science, and these were highlighted by others before me, is that science is very self-critical, and we make these criticisms of our own work so that we can correct them. So many of the issues presented in the 1980s have also been addressed now, but the privacy of volunteers, I think, volunteers in our clinical experiments is still top of the mind. How do we maintain that, especially with the electronic medical record? And then new recommendations that they made about data sharing is that funders should require data sharing. Journals should require access to the data. There should be repositories that will hear more about data in multiple disciplines. And there should be laws to protect against fraudulent data. And then finally, this emphasis about research transparency is a worldwide issue. And I think that's fantastic, but we'll talk about that. We have representation here from people around the world, which really shows, I think, that people are interested everywhere and doing research. So what I'm charged with doing is talking about design and measurement in studies, and that is reporting what was done in an experiment. Now, most of what I have on this slide is about reporting. And reporting is very important because, as I said, it's a major way that we transmit what we did in an experiment. But reporting doesn't ensure that the study was done well. All we have is the report. So reporting standards, reporting guidelines help you write down in a comprehensive way what you did. It doesn't help you if there's no report at all. And it also doesn't guarantee that the study was done correctly. It's very hard to report some things. You probably never will. Some people have said, well, maybe by writing down what should be reported, people are more easily able to hide what they didn't do because of lack of understanding, whatever. So that's a potential problem. I haven't seen it in the literature very much. Anyway, so we have a new era. The SPIRIT, for example, reporting standard is about how to report a protocol. And where protocols are now being required, at least in the clinical world, this can be very helpful then, because what is a protocol after all? So I just want to go over some of my language. It occurred to me that maybe not all of you are familiar with clinical trials and systematic reviews, but they fit in with what we're talking about. So a clinical trial is an experiment that's done in people, essentially, usually to see whether a particular intervention works or works well as a comparison treatment, which might be placebo, standard of care. It might be what's called a head-to-head trial comparing two active treatments. And then what we do typically is, or we have been doing for 20-some years, is to take all the results of trials, and you can do this with non-trials too, and you can do this in all fields, animal studies. It doesn't have to be done in clinical trials, but that's the world I'm in, is we combine the data both qualitatively and quantitatively in what's called a systematic review. So here, Madhur Pai has depicted what goes on in a review article. Let's say these are articles, could be what's called a narrative or traditional review, which means it's not systematic. It might be the literature you know, might be the literature you favor, but more and more, I think people are trying to be systematic about their reviewing, and that's that orange circle in there. Let's see if I have a pointer here. Oops, sorry, I guess not. You'll just have to guess. The orange circle is systematic reviews, and they're a subset of all narrative or traditional reviews. And that's what we do. You would take all the results of clinical experiments or whatever type study you're doing and put them together. And then a subset of systematic reviews contain the quantitative synthesis of the data, and that would be the computations that Victoria was talking about. And that's called a meta-analysis. And sometimes we have the data set from each individual study, and we do what's called an individual participant or individual patient data combination. And that's that teeny little dark blue dot. So that's just some language so that I know I'm going to forget, and I'll look, if you look bewildered, it'll help me remember I need to specify what I'm saying. So when you're talking about the role of evidence in healthcare, and which is very important, evidence-based healthcare, there are several steps. The first is evidence generation, which is in the clinical experiments or clinical trials. And then we synthesize the evidence in evidence synthesis or systematic reviews. Then policymakers, such as those who come up with guidelines, would go and say, what does the systematic review say? And you might have seen, for example, if you ever come across the clinical journals once in a while, you'll see, I saw this week in JAMA, the U.S. Preventive Services Task Force, which looks at screening and preventive services and makes guidelines based on systematic reviews. And then, and this is the hard part, applying what we know, the evidence, to actual health care. So it's one thing to have policy and another thing to do it. So this is the part I'm going to concentrate in what I talk about. So I'm going to show you from some data that actually are in press, and you can see the data online from Ian Saldana and his colleagues on AIDS HIV trials. I'm going to also show you some unpublished data from Evan Mayo Wilson and his colleagues. These data have been submitted but not accepted to a journal yet, and they're from a study called MUDS. And I'll also show you some other studies here and there, but the main bulk of what I show you will be from these studies. So I'll start with Ian Saldana's studies of outcomes. So these are measures. The outcome is a measure used in clinical trials. That is, did it work? What does that mean? It might be, well, did fewer people die of that disease? And so he looked at this and he said, well, what's looked at in the trials, how often do people measure the same outcome? And in systematic reviews, are they looking at the same outcomes as the trialists? Are we talking to one another? And I'm just going to show you data for clinical management, which would be, for example, treatments. So what he found is there is an overlap. That is, clinical trials, the clinical experiments are over on the right, and systematic reviews are the blue. And so there's an overlap of about 30% of the outcomes that are assessed by systematic reviewers and clinical trialists. And there are some outcomes that are in systematic reviews only. That's the blue on the left, the 10%, and some outcomes that are examined by the trialists only, which is sort of disturbing. Well, what would we expect? Maybe it's not disturbing. Maybe systematic reviewers are examining all the important outcomes. So what we expect is, if we have the percent of trials, there must be a pointer on here somewhere. It says danger. I don't know if I do. Okay. So what we have is the percent of trials reporting the outcomes and the percent of reviews reporting the outcome. What you want is that there's 100% overlap, right? So what you want is for all the trials and reviews to be in that upper right corner with overlap. Is it what we find? Well, if all the reviews did not talk about an outcome, this is a possibility, but the trials varied in whether they measured an outcome, you'd see this. If the outcome was popular among reviewers but not trialists, you'd see this. And you'd see this if it was popular amongst neither, and you'd see this if it was popular among both. That's what we want to see, right? Well, what did he see? He saw that sad face. He saw that what's popular with trialists is not popular with systematic reviewers. So how do we assess in an experiment whether a treatment or intervention works? Well, we do the trials and then we do the systematic reviews and we make policy, but they're measuring different outcomes. That is, how can we possibly determine whether this really works if we're not all measuring the same outcomes? Well, this has been recognized as a problem. And so there's a group called Comet, and they're based in Liverpool, and but they're worldwide collaboration. And what they do is they assemble where there's been a core outcome set developed. They don't develop them themselves, and whether patients were involved. And so the idea is that trialists and systematic reviewers should all use these core outcome sets, and they can measure outcomes that they want to as well. But at least we know they'll all be measuring the same things so that the data can be summarized for all of us when it's time to choose a treatment. So, well, that's very interesting. What other things are we talking about when we talk about the measures and the design and some of the things that Victoria mentioned? So I make the title bright blue to remind me that I'm moving to a different topic. So MUDS is that other study I told you about that where the data have been submitted but the paper's not published. And the whole purpose of this study, which is finished now, was to look at two different topics, and I'm only going to present to you the gabapentin neuropathic pain trials, to look at two different topics and say how often are the methods and the results reported in multiple sources, and do these multiple sources always agree, because we want the methods to agree and we want the results to agree, and if they don't agree, why not? So what we found doing a comprehensive search for just this outcome, and this pair of indication and drug. And I'm not going to show you the data for the other indication intervention pair because it just would take too long. So we found 21 trials, but they were reported 80 different ways. They were reported in journal articles, conference abstracts, trial registry, FDA, etc. And sometimes they were also reported not in public. And that is, there were some data that were provided in what are called clinical study reports and individual patient data sets. These are usually kept with a company that does the clinical study reports are more drug company related, but not necessarily the data sets. But the reason we had these, and one of the reasons we chose these two topics, is we knew that we could find the non-public sources, and we wanted to compare those with the public sources. Because now we have a lot of open science, and we wanted to see what could we learn by open science, et cetera. Does it agree? So, as I said, there are several things that we're looking for then in design and methods. The participant, for example, the number randomized in an experiment, the intervention and its comparator, for example, what were they, what was the treatment, what was the dose, and the outcomes, and I've already talked about Ian Saldana's findings there, but I'll also talk about MUD's findings. Were there variations in how the outcome was measured and how the data were aggregated, the time at which it was measured, et cetera, and adverse events. And I'm not actually going to talk a lot about adverse events because we just don't have time. But this is a growingly important area, especially for patients. So let me just explain outcomes quickly. An outcome, what you and I and probably many of us talk about as an outcome, is just a piece of the whole story. It's called the outcome domain. For example, we might say pain, or we might say anxiety, or we might say death. But if you're actually doing the computation, that's just one piece of how you actually do the computation. So another is, well, how did you measure anxiety? You use the Hamilton Anxiety Rating Scale. Or if you're doing pain, you use the McGill Pain Questionnaire. And people measure these things all different ways. There are standard validated measures, but there might be more than one. Also, what did they use then to see if there was an effect on the outcome domain using this specific measurement? And that would be the metric. So was there a change from baseline with this intervention? Was there some sort of value at a particular time point, which often you will see in a randomized trial? So what was this metric that was used? And I think there's a great deal of misunderstanding about this. And this is handled at the analysis phase. It's not handled in the design phase. How did you aggregate the data? That is, did you show a median or a mean or a change? What did you use? A mean change. And when did you do the measuring? Was it at 6 months? Was it at 8 weeks? Was it at 12 weeks? Was it a year, 2 years? And when the measurement was done, I'm correcting papers now for a class I'm teaching. And it's amazing how people say, we'll just take whatever measurement is used. Well, you really can't do that because what happens at 6 months after an intervention might be quite different from what happens after a year. So this time point is very important. So I'm more and more, and this really has only recently come out, Deborah Zarin at clinicaltrials.gov really, I think, forced this issue with how you report in clinicaltrials.gov. But I see at meetings that I go to that people are growingly aware of this very quickly, and this isn't more evidence that I think science corrects itself quite well. But we saw some problems in the data that we looked at, and that is that if you just specify your outcome domain, here I give the example of pain, there are many, many ways by the time you get through those 5 elements of an outcome, all of a sudden the different numbers of ways that you can present your results is huge. So this is just an example. If pain is measured using the McGill Pain Questionnaire, 0 to 10 scale, and there are all these other different measures that could be used, you could come up with 8 outcomes, you could come up with 10 outcomes, whatever. Then value at a time point change since baseline, what's the metric that you're using? All of a sudden, with changed metrics and the changed measures, you could have many different ways. You could have, in this example, 16 different ways of outcomes, essentially, what we call outcome. Then you have methods of aggregation and time points. You could measure using different populations, and I'll talk a little bit about that. That is, did you drop people out because they didn't comply? Did you leave them in? And that's what we're calling different population. So you can see that by the end, we have this big box of yellow, blue, red, and green, and those are the number of outcomes you have based on the different ways that it could be measured in your trial, in your experiment. And so when people say we got this outcome, it could be quite different from the next study that was done. And we have to be very specific about what we do. So what we did then is we went in and looked when a trial, a clinical experiment had both a journal article and what's often hidden data, non-public data, the clinical study report. And by the way, academics don't have clinical study reports, and they're wonderful. They're huge, they're long, they're like 8,000 pages. But they're also very, very informative, and they've already done some data analysis for you, presumably correct data analysis, and they've told you exactly how they've done it. So in these 5 trials where we had both, we compared the outcomes. And we said the outcome had to be fully defined. It had to have all 5 elements so that we could actually compare and see how often they agreed. And it turns out, when you look at the total of fully defined outcomes in each of these trials, there are lots. There are lots. It ranged from 42 to 82. And most of them were in the CSRs only. That is the non-public data. So studies measure a lot of data that they don't tell you about in a journal article. And there's more to this story. In fact, it allows both the trialist and the systematic reviewer to tell you what they want to tell you based on the data that are out there, that it varies so much. So then not only are the data not always fully defined in terms of the outcome, but sometimes you can't meta-analyze the outcome. So you want to do a systematic review of all the data out there, but you also want to do a meta-analysis of the quantitative data that are from each trial. But you can only do that if you have all the information you need, which includes a standard deviation. So how often did we find meta-analyzable data? Well, it varied. So there was hardly any meta-analyzable data when we looked at conference abstracts, where you might expect to find different outcomes, but really it wasn't worthwhile. But if you looked at an FDA report, for example, it was all meta-analyzable. And if you looked at the clinical study report and the individual participant data, which is a data set, it's all meta-analyzable. And so, so if you're trying to say, what do we know, not just from one trial, a clinical experiment, but from all of them together, you really need to access data other than what's in the public domain to be able to do a proper meta-analysis and see what works and what works best. All right. So you can have, this is a different study. So you can have a systematic review and meta-analysis that has lots and lots of trials addressing the same question. So you don't need to read this, it's unreadable. But what you do need to see is every entry over there on the side is a different clinical trial addressing the same question. And this question is exercise for improving balance in older people. And so you can see I didn't count that, but let's say it's 50 trials, even if it's 25. But it turns out, since they all measure different outcomes and they're not all meta-analyzable, that in fact, when they try to do the meta-analysis, and this is just one of them, the timed up and go test, but I didn't select it for looking terrible. Essentially, there are lots of meta-analyses, but they each only include 4 trials at the most. So here we have, let's say, 50 trials out there measuring how exercise can affect balance in older people, but we can't do the meta-analysis on all those trials because they're all measuring different outcomes, and they aren't providing the meta-analyzable data that we need, which is means, it might be all 5 components of the outcome, as I talked about, the elements, the means, the standard deviation, et cetera, so that you can do the meta-analysis. Okay, so this is just the number of variations that we saw, but it also introduces something that I think Victoria was talking about, which is the treatment effect, and you need a computation for this. So we talked about outcome variations already, but with the treatment effect, you also want to know who was analyzed. Was everyone randomized, also analyzed, or were some people dropped out? And I always remember an episode of ER, remember that TV show, where the head of some unit, I don't know which unit it was, decided to drop out from his analysis all the patients essentially in whom the intervention didn't work. And so that's an extreme end of what happens, but maybe he wasn't taught that you really can't do that. You have to include everybody, even if it's not intuitive. So the analysis the treatment effect includes the analysis population, who you included, how you handled missing data, which can be big. It can be people who didn't come back for a visit, who just didn't supply, for example, a quality of life diary that you asked for, or who withdrew consent, how you did adjustment for different variables in your study, And so all those things that comes down to what's the treatment effect. It's not just the outcome, but what's the effect on treatment. It includes these other components and how you did the computation. That's hardly ever there. And when it is there, there are a lot of variations that are given. And so again, it's hard to compare the treatment effect from one study to the next, which is what we want to do if we're getting to evidence-based healthcare. So in summary, from the MUD studies, many trials are reported multiple times. The reporting of participant intervention, comparison, and outcome is often unclear. Many outcomes are measured for a single domain, and it's possible then that an investigator could select which one to present. I didn't show you the data. It also could be trial and systematic review or investigator, so that you could have a selective outcome reporting and show the data you think are most important. Much of the data in these sources is not meta-analyzable, and when it is meta-analyzable, it doesn't mean it's the same data so that you can combine them in a meta-analysis. So I just want to talk briefly about post hoc specification, and this is saying after your study is already done, what you did, and treat it as if it was what you were planning all along. So I think, again, teaching is the real issue here. We have to make sure to teach and model proper behavior as scientists to our students. And it's hard because it means taking more time to, say, write a protocol and make sure that protocol is complete. So let me just show you an example. This is an example from no particular place. We have a clinical experiment in neurology. It's a surgical intervention. The protocol says our primary outcome is the percent who have a score less than 3 at 1 year. And then when we do the analysis, we find that the results aren't statistically significant. So when we write up our results in the publication, we write a different primary outcome, and we look at the percent who are dead or dependent on others at 1 year. And there we get a statistically significant outcome. This is a no-no. You say ahead of time what you're going to look at as your primary outcome, and that's how your sample size is estimated, and then you do it regardless of what you get. And hopefully you're looking at as secondary outcomes, other outcomes that you're interested in, such as the percent dead. Oops, sorry, I don't know how to go back here. And sometimes you come up with ad hoc outcomes that you didn't have in your protocol. Just say it. Just say that that's what you did. And we model it to our students. So the first study that really looked at this kind of thing, that was a big enough study, was from Anwen Chan. And he did this work as part of his doctoral thesis. And it really started off a snowball effect and got other people looking at this problem called selective outcome reporting. What he did is he compared protocols that were put to an ethics committee, and 2 of them in Denmark, and then he looked at the publication to see how often the protocol and the publication agreed on the primary outcome. And what he found is almost 2/3 of the time there was disagreement in those outcomes. And it looked like the reason for disagreement was statistical significance of the outcome. So he found other problems too. When he compared the outcomes to the protocol to the publications, he found differences in the sample size calculations, how protocol deviations were handled, missing data, some of the things I've already mentioned. So this implies that we have to be true to our protocol, or we have to write a protocol amendment that's clear to everybody and dated properly about changes. Because we always say a protocol is a living document. You really do change. And so these amendments have to be allowed. You just have to be upfront about them. So I'm going to show you now some more data, not from the MUD study, but it was also done on some gabapentin data for other indications. And this was done by a former graduate student of mine, Swaroop Vidula, where he looked at not only neuropathic pain, but also migraine, bipolar disorders, and nociceptive pain. And what he looked at is he compared the protocol for the original trial with the publication. And the protocol was available because, again, we had access to it through these sources. Okay, so you can't read this, so I'm going to tell you what it says. What it says is that And there were only a small number of studies where he had both the protocol and a publication. Studies weren't always published, and we didn't always have the protocol. But in these studies, he found 21 outcomes in the protocol that were specified as the primary outcome. And what he found is that most of them weren't reported in the publication or reported as a primary outcome. As a matter of fact, only 11 of the 21, so about half, were reported as the with no changes, including the primary outcome. But somehow before the publication, 12 new primary outcomes were identified and added to the publication, and what had been called secondary outcomes were also added, so that in the end there were 28 primary outcomes in the publication, but only 11 of them were original to the protocol. But this was not specified. Well, why did this happen? All right, this is sort of a complicated graph, but I'll show it to you. So this is the p-values that were in the primary outcome that was defined by the protocol if you look in the clinical study reports. And you can see below that line, above that line is not statistically significant, and the line is statistical significant. So there are only 3 studies that have statistically significant outcomes for the primary outcome that was designated in the protocol. But then if you look at the publication, again, below the line is statistically significant. What was published as the primary outcome is published as statistically significant. And 2 studies, and then 2 on the line, in the publication said that the primary outcome was not statistically significant. So I don't know if I can go back. So if you look at the protocol-defined outcome, very few are statistically significant. Then if you look at the publication, most are statistically significant of what was claimed to be the primary outcome. So it's what you could call a smoking gun. That is, was what was presented in the publication statistically significant because there was manipulation, or is it just innocence? And in my own experience, there's a lot of innocence here. I know, because people really think that's what journal editors want, statistical significance, and they may not realize how important it is to report the primary outcome that was originally specified and not to do data dredging. So I'm just going to briefly cover the risk of bias. That is, all of you would say, well, what's the quality of these studies anyway? And so we call risk of bias as a surrogate for the real measurement of quality. And we do all sorts of measurements in clinical trials that we call related to bias. One is, was the study randomized? Could people see the sequence ahead of time so that you could change who would get which treatment? Are participants and outcome measures and providers masked to the treatment? How were missing data handled, et cetera. And so if it's yellow, it means you couldn't tell what the risk of bias was. You couldn't assess the quality of the study from the publication. If it's green, it means all is okay. If it's red, it means it doesn't look too good. And if it's a black dot, it means there was really only one study, so only one publication or report. And so when there was only one, mostly you can see it contributed to unclear. And sometimes we got clarity when we looked at more than one report, which implies if you're doing a systematic review, maybe you should look at more than one report. You can find what's there. It's just you've got to look pretty hard. So that's the only slide I'm going to show about the quality of studies, but basically it's hard to tell the quality because it's unclear most of the time. Sometimes you can achieve clarity by going to more than one report, but that's a lot of work. So, and this also highlights something Victoria said, which is from Paul Glasziou, and he's done some work on whether you can actually reproduce the treatment regimen, the intervention that is being talked about in the report. And he found basically you can't. They did write to all the authors of these reports and ask for clarity, and that's what finally means. They often didn't hear from them, and sometimes they did. So you can see that after writing to the authors, maybe up to 90% of the time for trials, they could find out what actually happened so that the work could be replicated. But if you look at the reports, it's very hard to replicate findings. So that's all I'm going to say, but he's done quite a bit of work on replicating or reproducing a study's treatment regimen and how difficult it is to do from just using a report. And you can see by writing to the authors he had better luck. Okay, so in 2014, Lancet did a series on research waste. So one could say, well, if you don't do this right, this is a waste. And I think it's had a huge impact. There were 4 main papers, and there have been papers since then, including by people in the audience, talking about how can we reduce waste. We want to reduce waste in science, so let's do it right. And so I think by calling attention to these things, we can do better, and teaching our students where to do better. So I think all in all, where we're moving is to an open science world. That is where we submit our protocols and our data sets and maybe even more to try to get at what really happened. But it's too much stuff. That's all of us who are working on the MUD study, we called it MUDs for a reason. It was like overwhelming. And we found that our results are overwhelming readers too. We have a lifetime of analysis that could be done there. There's a lot of data out there. And somehow we need to reduce or consolidate the number of data sources. And I think that open science will help with this because we'll identify the data sources that are most useful and maybe we can stick with those. Already we're saying don't bother going to abstracts for information. In the end, you won't get meta-analyzable data if you're a systematic reviewer. So the question for all of us and for others is how many open sources of data do we actually need? So we're of the mind, well, it's good to have a data set. Most people really don't have the resources to analyze the data set, nor do they necessarily know how. And so those clinical study reports that industry puts out are, except for being really long, you already have the data aggregated. And as long as everybody's putting out there what you need, you can get a fair amount of information from them. So I think some discussion needs to happen there, and you can do a meta-analysis. And we'll just need to come up with best practices and make sure that they're followed. So what do I think we should do based on what I've shown you? I think we need to improve the reporting of trials, and I really like the idea of more about computation. I absolutely agree. The population intervention comparison need to be better described, the methods, what was done, the risk of bias, the outcomes. We need to be much better about defining all 5 elements. We need more core outcome sets that involve patients. So it's not just what I think about what needs to be in a core outcome set. We hear from the patients about what they want. And then in terms of results, we need to make the study protocols public as well as results. And we need to report the data fully and consistently and report the adverse events. I didn't talk about adverse events here, but it is an issue. And it's something that patients are really interested in. And then I think we still have a lot to talk about in terms of non-public data. Right now, as you'll probably hear over the next few days, some of the data that was previously not public is being made public but behind firewall. So it's very hard to get hold of it to actually manipulate it if you have people who can do the computational work, for example, in a meta-analysis. So that's all I want to say about the design and operational items that we're going for. And we have some things to clean up. I think as teachers, we can model and also teach how we want students to do their work, whether it's conducting an experiment or synthesizing the results of experiments. Thank you.